Hey guys, welcome to the next section. This is going to be a bigger section because we're going to actually talk about three different shapes in this particular section and just morph it all into one. So make sure you're ready to take some good notes and write down all the rules and examples. That way you have them to refer back to. So today we're going to be talking about rectangles, rhombi, and squares. And just know rhombi is the plural for a rhombus. Okay, so I have listed here the three basic definitions of each of these shapes. Obviously, you want to write these down. So, a rhombus is just a parallelogram that has all sides congruent. Okay? So, if I've got a little picture here, I could say that every single one of these sides are equal to each other. A rectangle has all interior angles that are 90 degrees, so all right angles. So, here we know that these are going to be 90-degree angles. Okay, and then a square is a combination of the two. So a square has all right angles as well as all sides congruent. And some of these hopefully we know, especially rectangles and squares. You guys are familiar with those, but the rhombus may be kind of the new one. Now, one thing I want to emphasize, I'm not going to write this down, but every single one of these new shapes still have all the rules of parallelograms. So we can still talk about opposite angles being congruent. We can still talk about diagonals bisecting each other. Opposite sides are parallel and so forth. And just as a visual, if it helps you, okay, here's a Venn diagram showing how all of these different shapes are related. So obviously on the most generic scale, we have our parallelogram. So those are all on the outside of this Venn diagram. And remember, parallelograms, all we know are opposite sides are parallel. That's its definition. And then we start to get more specific as we go into our shapes. So rectangles are still parallelograms, okay, but they just have four right angles. And rhombi are still parallelograms. They're inside this Venn diagram, but they have four congruent sides. And then notice how we said earlier, squares have four right angles and four congruent sides. So squares are basically just a combination of rectangles and a rhombus. So it's the mixture of the two. The first two examples we're going to do in this section deal with this Venn diagram. So the first one says, is a rectangle always, sometimes, or never a square? So if you take a look at your diagram above, notice that a rectangle has a square in it. Now, a rectangle, all we know, means that we have four right angles. So can a rectangle ever be a square? Well, yes, of course it can. It's the most specific case when it has four congruent sides. But a rectangle doesn't have to have four congruent sides. It can just specifically have four right angles. So this is one that's going to be a sometimes answer, because sometimes it's going to be a square with four congruent sides, but sometimes it won't have four congruent sides. It may only have opposite sides that are congruent, like this. So it applies to both because they can be within the same oval. Sometimes here, but sometimes on the outside. All right? But then number 2 says a square is a rhombus. Well, notice the square, we said earlier, is made up of a rectangle and a rhombus. So a square has four congruent sides, and it always will, and so does a rhombus. So this is one that's an always problem. All right, now we're going to get into a couple theorems, some new theorems about each of these different shapes, and these are going to be something you want to refer back to just like we did in the parallelograms. So the first one deals with a rhombus. So it says in a rhombus the diagonals are perpendicular. Just as a reminder, the symbol for perpendicular is an upside down T, just like this. And remember, perpendicular means, okay, that it creates a right angle. So if you look at our diagonals here, let me highlight these. So here's a diagonal, and here's a diagonal. Notice that these two diagonals cross to make these four right angles. So no matter what, our diagonals are going to have right angles in the corners. And that's actually going to be really helpful because now we have these nice right triangles, and later you're going to see this example of where I can use Pythagorean theorem to solve for different side lengths. And also notice that even though we didn't talk about it, our diagonals are still split in half, and that's because it's still a parallelogram. So this part is still congruent to this part, and then this top left is congruent to this bottom right. So that rule still applies. The new rule is about the angles. Next rule about a rhombus is that the angles are split in half. So it says in a rhombus, opposite angles are bisected by the diagonals. Before, and when we talked about parallelograms, we couldn't assume that the angles were split in half. So if you remember, this was back to the old examples, we'd be given a parallelogram, and the only things we would know are that these would be alternate interior or something like that. Well, now we can tell that these angles are going to have to be congruent. So we could say, for example, angle 5 has to be congruent to angle 6 now in a rhombus. And angle 1 would have to be congruent to angle 2. And angle 3 would have to be congruent to angle 4. And then angle 7 now has to be congruent to angle 8. So this will be really helpful because now we just learned that these are right angles here in these corners. And now we know that the angles are split in half. So I could, if I told you an angle measure here, I have a nice triangle and I could find the third one. All right, so we're just using measures of triangles here. All right, next rule is about a rectangle. A rectangle is going to have two diagonals that are congruent. So before, we didn't know anything about diagonals except they split each other in half. Well, now we can tell that the whole diagonal, so from A to C, let me scroll my picture down, so from A to C has to be the same as B to D. And the bisecting part still applies, so these two things are now the same, and these are still the same, okay? And so by saying now the diagonals are congruent, we actually know that all four parts of the diagonals would have to be the same as well. So it's going to be very useful. So specifically in a rectangle, diagonals are now congruent, okay? So let's just jump into a couple examples. We've got quite a few here that we want to go through just as a variety, but just make a side note that these are not the only examples that you're going to need to know. So you're still going to need to know all the rules and how to use them. I'm just going to throw a couple at you, and then if you have questions on other rules in class, of course, make sure you ask. So in this particular shape, it says EFGH is a rectangle. And it says that KF is 3x minus 5, so I'm going to label my picture. So that's that segment. And then KH is 2x plus 11. And they want us to figure out what EK is. So they want us to find this segment right here. All right, so we're dealing with a rectangle. Well, the nice thing is we just said in our last example that in a rectangle, diagonals are congruent. So what that means is that we can use two rules here. Well, we know it's a parallelogram, so we know that from K to F and from K to H, those have to be the same. So I'm just going to say 3x minus 5 is equal to 2x plus 11. So remember, diagonals bisect each other, so I can make these equal. So I'm going to solve here. I'm going to subtract 2x over, and I get x minus 5 equals 11, and then I can add 5 to the other side, and you get x equals 16. If you have trouble with the algebra part of this, please make sure you show your work, okay? That way I can follow what you did. So we got x was 16, but that's not what they wanted. They wanted what e to k was. Well, remember that in a rectangle, diagonals are congruent. This is important. So that means that this portion here has to be the same as these. So it might have to be the same as this one or this one. So what we can do is take the x value and plug it in here. And if I know this, then I automatically know EK. So I could say EK is equal to KF. So if I know what KF is, I could plug this in. 3 times 16. And then subtract 5, then automatically I can know what EK is. So when I solve, let's see, I get 48 minus 5, and so I get that KF is 43, which automatically means then that EK is equal to 43 as well. That's exactly what I'm looking for. Okay, so this just requires you to know that the diagonals are congruent. So if I set up an equation, then I can plug it back in and solve. All right, next example, same exact picture, but we're going to be working with something different here. So it says EFGH is a rectangle. Okay, so we're still dealing with a rectangle, but this time we're going to be working with the angle measures. So here it says angle EFH. So EFH is this angle here. Okay, it says that's 2x minus 7. And then it says HFG. So HFG is this angle here, is 2x plus 5. And they want us to find what EFH is. Okay, so they're looking for the top angle. Well, we don't know in a rectangle anything about the angles except that they are all right angles. So this is very important. Okay, so the fact that we have right angles. So here, these two angles together are going to make a nice 90-degree angle. So what I can do, instead of making these equal to each other, because we don't know if they're the same, we can add them together. So we can say 2x minus 7 plus 2x plus 5 has to equal 90 because this corner angle is a 90-degree angle. And then I can just go ahead and solve. So combining like terms, 2x and 2x is 4x. And then negative 7 plus 5 is negative 2 and equal to 90. So then I can add 2 over to the other side. So I get 92. And then I can divide both sides by 4. So those cancel. So here I can take 92 divided by 4, goes into it twice. Okay, this is good practice if you're not sure or you don't have a calculator, okay, doing that long division. So you get x equals 23. Okay, so don't always rely on that calculator. You guys can always do the division off to the side if you need to. So we get x is 23, but they want the measure of angle EFH. Well, we get lucky here because EFH has an equation. So all I have to do is plug my x value back in right there. So I'd say 2 times 23 and then subtract 7. So 2 times 23, we get 46 minus 7, and that's going to get us 39 degrees. So there's our final answer. Okay, so that means that this little angle right here is 39 degrees, and we'd be finished. Okay, so if you have any questions about this one, knowing that in rectangles you have 90-degree angles, hopefully that helps you set up your equations. All right, we've only got 3 more examples, and then we'll be finished, I promise. This time we're dealing with a rhombus. So remember, a rhombus has all congruent sides. Okay, so that I'm just marking this even though we don't need it necessarily. Okay, knowing that they're all congruent sides, and also we know in a rhombus that all the angles are 90 at the diagonals. Okay, so there's a 90, here's a 90, all 4 of them. Okay, so that's going to help us to maybe label a few things in our picture. And here they tell us FK is 5, so this right here is 5. And then they tell us from F to G is 13. So keep in mind that we know that if this is 13, every single side is 13. Okay, so I'm just labeling what I know. Okay, and we still know that diagonals bisect each other. So if we know FK is 5, that means that KH is also 5. So I'm going to label this here. And they want us to find from K to J. So I'm wanting them to find this segment. Well, if you look here, we've got this nice right triangle. So I'm going to highlight it. Okay, so we've got this here, here, and here. Okay, we've got this nice right triangle. So, and we know it's a right triangle because at the diagonals it's a right angle. So I've got this picture. I'm just going to take it out here. We've got a side that's 13. This is 5. That's the right angle, and we want to know what this is. Well, if we have a nice right triangle, use Pythagorean theorem. So a squared plus b squared equals c squared. This is a formula you guys should know. So we just have to plug in a, b, and c. Well, the hypotenuse is 13, so that's our c squared. So 13 squared. And then we don't know what a is, so I'm just going to leave it as a squared. And then b squared is that 5, so b would be 5, and you plug it in. So now we have to simplify. So we get a squared plus 25 equals 169. And then we can go ahead and subtract on both sides. So subtracting 25 over, we get, I'm going to bring this over here, a squared is equal to 144. And then we can take the square root of both sides, and we get that a is equal to 12, which a in this case is exactly what we wanted. This was from k to j, so we could say that kj is equal to 12, and we'd be finished. So a rhombus is really nice. A lot of the times when you're dealing with a rhombus, you can use Pythagorean theorem because you have 4 right triangles. All right, next example is a square. So we're just going to throw in a square example here. And remember I said these are just random examples, but there are many, many more options of things that you're going to want to make sure you pay attention to with these shapes. So having your rules handy is going to be very beneficial. So here it's a square. So they already have the 4 90-degree angles marked for you, but remember also 4 sides are congruent in a square. So it says if WT is 3, so WT is right there, they want you to find ZX. Well, ZX is the whole diagonal. Well, remember, a square is made up of a rectangle and a rhombus. So anything that applies to either of these shapes applies to this. So in a rectangle, we learned the diagonals are congruent. So if I can figure out what WY is, then I can automatically figure out what XZ is. Well, if WT is 3, that means that from T to Y also has to be 3. So that means here that my whole diagonal WY is equal to 6. And because our diagonals are congruent, that automatically means that Z to X also has to be 6. So notice there's very little work for some of these problems. You just have to know what the rules are and how they're related. So I knew that diagonals in a square had to be equal because it's made up of a rectangle. And so I just had to find the whole length and then just make it equal to the other one. All right, so very little work, but you might have to justify why you got what you did. All right, and then the last one, find the measure of angle WTZ. Remember, follow our letters, W to T to Z. Well, this right here is what they're looking for. And remember, where the diagonals meet, when we talk about a rhombus, we knew that it is made up of a right angle at the diagonals. Well, because a square is a rhombus, we automatically know that this has to be 90 degrees. So you'd say the measure of angle WTZ is 90.